All right, 1.6. We're going to talk today about solving equations. Solving by factoring, right? We always try and factor. Then we're going to do some that involve radicals or square roots. And then we're going to do something with rationals. And we'll talk about that at the end. That's probably the hardest that we're going to do. The beauty of solving equations is you get a number that says x equals. What can you do with that number that you get to see if you're right or not? You can plug it back in. So when you turn your quiz in on Tuesday, you guys should know, I made 100. I know I got 2 wrong. I couldn't figure out what was going on, but I know these ones worked, these ones didn't. Okay, that's really important for you guys to understand. Now, when we look at something like number 1, it says solve the equation. All right, when we try to solve an equation, guys, and you have exponents, it's the same variable, right? But you have exponents. Always set everything equal to 0. Let's move everything to one side. Let's move everything to one side. So this becomes x to the 5th minus 9x cubed equals 0. When we're solving equations, the highest exponent you see will tell you how many answers you should have. So how many answers should I have here? 5, okay? What that means is if you were to graph this, it would cross the x-axis 5 times. So the first thing we do, guys, if we're going to solve by factoring, we look for a what? GCF. Is there a letter and or number that I can take out of x to the 5th and 9x cubed? I can take out x cubed, right? And I'm left with x squared minus 9 equals 0. Yes, ma'am. Do you guys see anything here?
You can simplify it.
How can I simplify this?
X plus 3x.
Ooh, very good. Difference of perfect squares. So I have x cubed times x plus 3, x minus 3 equals 0. So now we're just going to solve. You set each piece equal to 0. So I have x cubed equals 0. I have x plus 3 equals 0. And x minus 3 equals 0. When we solve by factoring, it's going to factor pretty. You just have to figure out, is it the difference of perfect squares? Do I multiply a times c and break it down? It's going to be some sort of factoring. But over here on the left-hand side, how do I get that 3 to go away? Cube root. If it was a 2, you take the square root. So you take the cube root of this side. What you do to one side, you do to the other. It's not an even root. If it was a square root, 4th root, something like that, you put plus or minus, but it's not. So this crosses out. What number times itself 3 times gives you 0? There you go. Good. You have 0 3 times here. We'll talk about multiplicity later. Not anytime soon, but now what do? Minus 3 from both sides. So I get x equals negative 3. And then what? Add 3, and I get x equals positive 3. Now, what can I do with all 3 of these answers? I can plug it back into my original equation, and I get the left side equals the right side. That will happen every single time you are solving an equation. Questions? All right, let's look at number 2. We're going to solve by factoring. So if we're going to factor, the first thing we look for is a GCF. And then we look for, is it a trinomial? Is it a perfect square? Something like that. So I have negative 6x cubed minus 20x squared plus 16x equals 0. Is there a GCF? Negative, good, 2x. We lead with a negative, so take the negative out. So I have negative 2x. I'm going to take out of all 3 of these. Your negative 2x goes out in front, and I'm left with negative 6 divided by negative 2 is 3. And then I have x squared. Negative 20 divided by negative 2 is positive 10x. And then positive 16 divided by negative 2 is negative 8 equals 0. So now we say, okay, can I factor this more? This is a trinomial. How do you see if you can factor a trinomial? Perfect. A times c. 3 times negative 8. What are the factors of negative 8? That'll give me a negative 24 when I multiply, but a positive 10 when I add. Ooh, very good. 12 and 2. X plus 12 and x minus 2. I know some of you saw 6 and 4. But if you had 6 and 4, in order for it to be a positive 10, you would have to have a positive 6 and a positive 4. If I multiply that, it won't give me a negative 24. Now, do I leave my parentheses like that? Why not? You got to divide by the a term. Perfect. So divide here by 3 and here. So I have negative 2x. This becomes x plus 4. And then this becomes what? 3x minus 2. And all this set equal to 0. Now, none of this is new. We've done all this stuff. The new part is to set each parenthesis what? Equal to 0. So I'm going to say, all right, I have negative 2x equals 0. X plus 4 equals 0. And 3x minus 2 equals 0. Divide both sides by negative 2. And x equals what? 0. Good. Minus 4 from both sides. And x equals what? Negative 4. Awesome. And now I'm going to add 2 to both sides. So 3x equals 2. Then do what? Divide by 3. And x equals 2 over 3. Now, how many answers do I have? 3. What's the highest exponent you see? Good. What can I do with all 3 of those answers separately to know, oh, I got this one right? Plug it back in. Great. Question. All right. I'm going to factor this. First thing I look for is a GCF. Is there one? No. There's 4 terms. What should we try and do? Group. Again, this is nothing new. We've done this before. What do I take out of the first set of parentheses?
X squared.
X squared. Awesome, guys. So I'm left with x plus 3. Okay, what do I take out of the next set? Negative 4. It leads with a 4. Take the 4 out. So I'm left with x plus 3 equals 0. What is my new GCF that I see? Good. So we take x plus 3. We write it one time outside. And what happens with my leftovers?
X squared minus 4.
Awesome, guys. X squared minus 4. Can I factor that a little bit more?
Yep.
Yes.
That's the difference of what? You're right, though. It's the difference of perfect squares. What is it? X plus 2 and x minus 2. Now, when we set each parenthesis equal to 0, x plus 3 equals 0. Well, what's my x value here? Negative 3. What's my x value here? Positive 2. Negative, sorry. And then what's my x value here? Positive 2. Oops. What is the highest exponent you see? 3. How many answers did we get? 3. What can I do with all 3 of those answers to go, oh, good job, I got this one right? Plug it back in. Good. Do you have to? Am I requiring you guys to? No. Do I think it's a really good idea if you do? Yes. All right, how are we going to solve this? We look for a GCF. Same thing as we already did. Is there a number and or letter that goes into all 4?
No.
So we're going to do what? Same thing as before. We're going to group. Good. What can I take out of 4x cubed and 3x squared?
X squared.
Just x squared. And I'm left with 4x minus 3. Good. What about negative 16x plus 12? Take out a negative 4. And I'm left with 4x minus 3. Well, isn't that pretty? What's my new GCF? 4x minus 3. And then what am I left over with? X squared minus 4, which becomes what? X plus 2x minus 2. You guys will start to see there's patterns because there's only so many ways that we can make these problems pretty. There's only so many things we can do. Now, if you can solve in your head from here, that's fine. If you can't, then write down 4x minus 3 equals 0. Add 3 to both sides. 4x equals 3. Divide both sides by 4. And x equals 3 over 4. Don't be embarrassed if you do that. I'd rather you do that and get the answer right than try and do it in your head and get a sign wrong or something. Because if a sign is wrong, is it a solution? No. So if you need to write x plus 2 equals 0, subtract 2 from each side and get x equals negative 2, good for you. If you need to write x minus 2 equals 0, add 2 to both sides and get x equals 2, not a problem at all. We're going to solve now, guys. Look, these are called rational expressions. They're just fractions, okay? If I had this, could we do this? Yes. What do I have to get first? a common denominator. We're going to do the same thing here. Okay? We've got to get a common denominator first. We're not going to have a bunch of these on your quiz, but you will have one or two. So the first thing we're going to do is we're going to factor everything completely. Can I factor anything with x? No. Can I factor anything with x minus 3? No. So just put it in parentheses. Can I factor x squared minus 9?
Yes.
To what? X plus 3 and x minus 3. Okay, everybody do that with me. Take these steps and do this with me, and this will be okay, I promise. Now, when we talk about a common denominator, especially when we're talking about rational expressions like this, fractional expressions, look at each piece separately. Do you see how the first fraction has an x just by itself? The second fraction has a different denominator. It's x minus 3. Those two are together. It's not just that you can put a minus 3 on the other ones. And then the last one has x plus 3, x minus 3. So what we're going to do is we're going to write an equivalent equation to where we all have the same denominator. So watch what I'm going to do here. Okay, I look at this first fraction right here, and I look at all my denominators. What are the three different denominators you see? X minus 3, x, and x plus 3. I see three different things in the denominator. So we're going to make them all have the same. So I look at this first fraction of x. It has the x. What are the other two pieces that it's missing? So if I multiply this bottom here by x plus 3 and x minus 3, what you do to the bottom, you do where? So I'm going to multiply the top by x plus 3 and x minus 3. Okay? Now I'm going to look at the second denominator. The second denominator has what? The x minus 3. What does it need? The x plus 3 and the x itself. So then I'm going to multiply the top by the x and the x plus 3. Because it's right here. Our new denominator is going to have x, the x plus 3, and the x minus 3. We're just going to take all the different denominators and put them together. And then the last, look at your last fraction on the other side of the equal sign. It has the x plus 3 in the denominator. It has the x minus 3. What's it missing? X. Just the plain x. So if I multiply the bottom by plain x, then what do I do to the top? Multiply by plain x. Now that we have created our common denominator, we're multiplying everything on the top, but to make it all the same, you can cross the bottom off. And this just no, not all this was nothing. Now we have to do the math part.
So are they all canceled?
The bottom is gone. You've created an equivalent equation on the top. So what do I have to do first here? I have to FOIL. What's x times x? X squared. Then I have x times negative 3, x. 3 times x is positive 3. And then I have 3 times negative 3 is negative 9. What happens with the plus and minus 3 x's? They cancel out. So I'm left here with x squared minus 9. What was on the outside? The 3, right? So now I need to distribute the 3. Becomes what? 3x squared minus 27. Perfect. Whoops. All we're doing now is just simplifying the top. So now I have a minus sign. All right, this was my first simplification. Now I have a minus sign. I got to multiply. So when I FOIL or distribute here, I get x squared, what? Plus 3x. Good. And then what do I need to do with this 2? I'm going to distribute it. So 2, and here I have 2x squared plus 6x. Okay? That's on the left side of my equation. This is messy. It's messy, I get it. But once we do a couple more, you'll be okay. And then what do I have to do on the right-hand side of the equal sign? I have negative 12 times x gives me negative 12x. Now all we're doing is just solving this equation. What do I have to do with this minus sign before I can combine like terms? Good, guys. I have to distribute. So this becomes minus, and this becomes minus. So what's 3x squared minus 2x squared? X squared. Then what? Minus 6x minus 27 equals negative 12x. If I'm going to solve this equation, everything needs to be set equal to. So I'm just going to add the 12x to the other side. Do you guys see that I'm adding the like terms? Keep my x's together. So I'm left with x squared. What's a negative 6x and a positive 12x? Plus 6x, good. And then minus 27 equals 0. So now we say, can we do what? Can we factor? Is there a GCF? No. What about A times C? 1 times negative 27. 1 times negative 27. What can I multiply to give me negative 27, but add to give me 6? Perfect, guys. Plus 9 and minus 3. So this becomes x equals negative 9 and x equals positive 3. Now we have one more thing we have to do. Rationals are long. I get that. One more thing we have to do. Remind me again, guys. I'm going to erase this stuff. What can the denominator of a fraction never be? No, it can be negative. Cannot be what, Riley? 0. So I found one of my answers to be negative 9. If I put negative 9 in here, just check to see. That's fine. Negative 9 minus 3, that doesn't give me 0, right? Negative 9 squared is 81 minus 9. So negative 9 won't make my denominator 0, correct? Okay, so that's good. What about 3? If I put 3 here, that's okay. What about if I put 3 here? What's 3 minus 3? 0. So what does that tell me about the solution of 3? It doesn't work. You have to cross it out. It's something called extraneous. It's extra. You guys always, always, always have to check for extraneous solutions. Sean. All right, we're talking about rationals. We have fractions. Fractions, denominators can't be 0. So we'll talk about that at the end. But factor each denominator. I have x plus 2. I have an x minus 4. Can I factor this? Whoops. I can factor it into what? X plus 2 and x minus 4. I'm going to give you something that works nicely like this. So I look now and I say, okay, I've got to set up something that has a common denominator. What are all the different pieces of denominators that you guys have? Okay, what are they? Tell me. There's an x plus 2 and there's an x plus 4. Oh, my bad, thanks. So now look at each fraction individually. Each fraction individually, we're going to say, what does each fraction already have and what is it missing? So I look here at this first one. I have an x plus 2 in my denominator. What is it missing from the blue one? So if I multiply the bottom by x minus 4, guys, what do I multiply the top by? X minus 4. Perfect. Good. So now I look at my second fraction, and I say, okay, it has the x minus 4. What is it missing? The x plus 2. If I multiply the bottom by x plus 2, I do what? I multiply the top by x plus 2. Perfect. Now on the other side of my equal sign, I look at the negative 9. Compare the two denominators. Are they both the same? Okay, so now that they're all the same, what can I do with the bottom? I can drop it. Drop it like it's hot. Go. Now what do I do with the numerator? Distribute. So 7 times x is 7x. Then I have minus 28. Perfect. Keep that in a parenthesis because we have a minus sign in the middle here, so we want to make sure we get our signs all correct. Or, you don't have to. You definitely, well, okay. What kind of a 5 is that? It's a -5. So if you want to just distribute the -5, you can do that. Or some of you, whoa, what's going on here?
Why wouldn't you just distribute it?
Because some people would distribute 5 and then the negative in the middle. But I think it's a good idea to just say, okay, this is a -5, right? There's a negative sign right here. So I'm going to distribute -5. -5 times x is -5x. And -5 times 2 is -10. And then I have equals -9. Now, is this a quadratic? Do you have an x squared? No. So how many x, what's the highest exponent you see, I should say? 1. So how many answers am I going to have? Just 1. So combine, what's 2x minus 5x? Sorry, 7x minus 5x. 2x, I was thinking ahead. What's a -28 and a -10? Perfect. Equals -9. Now what do? I'm going to add 38 to both sides. So I have 2x equals, what's -9 plus 38? Okay, so -9 and 38 is 29 over 2, right? Okay. So then we take that, if you plug in 29 over 2 for x, either an x minus 4 or x plus 2, that will not make your denominator 0. So you guys are fine there. If you want to leave it as a decimal, you're more than welcome to. Decimals are something that's easier to work with. That's okay.
14.5. Right?
Yeah, that's fine. All right, look at this last one. This is the easiest one of all. What is underneath number 7, -7?
1.
There's a 1. Do you guys see here that we have a fraction equal to a fraction, right? There's one fraction on the left-hand side and one on the right. Yes? When you have just a fraction equal to another fraction, one on the left, one on the right, you can cross what? Multiply. Good. You can cross multiply. So we just cross multiply here to solve this. We say, okay, -7 times x plus 9. And then I have equals 8 times 1. Just cross multiply. When it's a fraction equals to a fraction, cross multiply. So take your -7 and distribute. I have -7x minus what? Good. Equals, what's 8 times 1? 8. Now what do?
Add 63.
I'm going to add 63 to both sides. So -7x equals, are we true? And then what's -7? What do I do with the -7? I'm going to divide both sides by -7. So I get x equals -71 over 7. Doesn't matter where you put the negative. Doesn't matter. What should I check to make sure does not happen? We got to make sure there's no extraneous solutions. We need to make sure when I take that -71 over 7, if I were to plug it in here, -71 over 7 plus 9, is that going to make my denominator 0? No. So then we're good. All right, when we have a square root, guys, okay, when we have a square root, these are a little easier to do. The first thing you want to do is isolate the square root. What does it mean to isolate? Get it by itself. So look, I'm going to circle this right here. I want that by itself. So what do I have to do? I have to subtract 1 from both sides. Agreed. So I have 2x minus 1 equals negative square root of 2 minus x. I still want this by itself. So what do? How do I get that negative to go away? How do I get the negative to go away? I have to divide by -1. So this becomes -2x plus 1 equals the square root of 2 minus x. Now that you're all by itself, this is the same thing we did with completing the square. Now that your radical is all by itself, how do you get that square root to go away? You square both sides. What you do to one side, you do to the other. Perfect, guys. So this becomes 2 minus x. What does -2x plus 1 quantity squared look like? This says -2x plus 1 quantity squared. That's what that 2 means. What does that look like?
Like a photo.
like a FOIL. Why? Because you have how many of those parentheses? You have 2. You guys had this on your first quiz and your first test. No, you didn't. Negative 2x plus 1. It means I have 2 of them, so you have to FOIL. What's negative 2x times negative 2x? 4x squared. What is negative 2x times 1? Minus 2x. What's a 1 times negative 2x? Negative 2x. And what's 1 times 1? Plus 1 equals 2 minus x. Do you notice here, okay, first of all, we can combine, right? 4x squared minus 4x plus 1 equals 2 minus x. All right, we have a quadratic because we have x squared. We have an x squared and we have an x. That means everything needs to be on one side, and we set our equation equal to 0. So I'm going to subtract the 2 and add the x. I'm going to subtract the 2 and add the x. So I have 4x squared. What's a negative 4 and a positive x? Negative 3x. What's a positive 1 and a negative 2? Negative 1 equals 0. Can I factor this? Yes. I'm not going to give you guys any right now that you can't factor because this is already a lot of work. I know that. So 4 times negative 1 is negative 4. What are the factors of negative 4 that multiply to give me negative 4, but add to give me negative 3?
X minus 4x plus 1.
So I have minus 4 and plus 1. All right. Do I leave it like that? I got to take my a term, divide it by each factor. So I have x minus 1 and 4x plus 1. And now I just solve each of those. So x equals 1 and x equals negative 1/4. How do we feel? Not bad. When you have a square root, what's the first thing you have to do? Isolate it. Good for you. Get it by itself. Let's look at number 9. Let's isolate the square root. Isolate the square root. So what do I have to do? Subtract 16 from both sides. So I get negative 3x plus 1 equals what? 4. Okay. Divide each side by? Divide by negative 1. So I have the square root of 3x plus 1 equals negative 4. And now what? Why? You want to get rid of that square root. So I'm going to square both sides. Perfect. When I square a square root, it goes away. So 3x plus 1 equals, what's negative 4 squared? Positive 16. And then now what do? Minus 1. 3x equals 15. Divide by 3. Good, Sean. X equals 5.
That was a nice one.
Yeah, that's pretty. That's pretty. You're going to really like 10 then.
My hand, they just cramp.
We're almost done. This is a long lesson, I know.
Brain is fried.
We'll spend a couple days. We'll spend a couple days going over this next week. I promise. I promise.
This whole week my brain has been fried.
It's okay. I know it's Friday. All right, last one. What do we have to do when we have equations involving square roots? Wait, hold on. We have to we have to isolate them. Good. Sean, you are on it today. They're already isolated. So what do? Just square. Square both sides. What happens when I square a square root? So 5x minus 1. Good. What happens when I square a square root? It disappears. So I have negative 3x plus 7. Now here, guys, look. Is this a quadratic? Do I have x squared? No, I don't have anything where it's like x squared and x and I have to move everything over. We have x's and we have numbers. Move your x's to one side, your numbers to the other, and then go.
Doesn't matter where you move them.
Doesn't matter where you move. If you want to move x's to the left and numbers to the right, that's fine. You want to do vice versa. I like everything on the left-hand side for x's, so I'm going to add 3x to both sides. And then I'm going to add 1. Everybody with me?
Yes.
So 5x plus 3x is 8x. Negative 1, positive 1 cancels. Negative 3x and positive 3x cancels. And 7 plus 1 equals 8. Now I divide both sides by 8, and x equals 1. What should I do with my x equals 1? Let's plug it in and check. You don't even have to think much, guys. Look, on the left-hand side, what is 5 times 1? 5 minus 1 is, and the square root of 4 is 2. Okay? Over here, plug in -1. What's -3 times 1?
3. I mean, negative.
-3 plus 7.
4.
4. What's the square root of 4?
2.
Does 2 equal 2?
Yep.
So you're good to go.